Okay. Yeah, welcome to today's class. The last class we did Radix point. So today I told you I was going to show you how to convert fractions between bases. We have also seen how to convert integers, right? Decimal to binary, binary to decimal, and then hexadecimal. So today I'm going to show you the fractional part, how to convert fractions between bases. So I have let's say I have 5.625, which I use. So this is base 10. Now I want to convert this to binary. So to convert this to binary, first, there is the integer part, which is the whole number part. And then there's the fractional part. So the same way I taught you how to convert decimal to binary, which is you are dividing by the base, is how you are going to deal with this part. But the fractional part is going to be the reverse. So you have division and multiplication. So for the part of this one, we are simply going to do it this way, which is what? 5, right? Now I'm going to divide it by the base, which is base 2. So convert this one to binary. That this convert to what? Binary. Now, binary is what? Base 2. So 2 go into 5. 2. Remember what? 1. Right? 2 go into 2. That is 1. Remember what? 0. Now 2 go into 1, 0. Remember what? 1. Then you measure it upward. So you are going to count 1, 0, 1. That is for this part. Now we have the radix point, which is here. Now we have to do what? Convert this part. Now to do that, we are going to multiply. So we have taken care of this part. So this one will now be 0.25. This one will be 0.625. That's what we have, which is the fractional part, because we have taken care of what? The whole part, the whole number part. And that has given us 101. Now, this part, we are going to multiply by 2. So this time, this will give us what? 10. You carry 1. Times 2 will give us 4, plus that one, 5. Times 6 will give us 12. So you put 1. Then you carry 1. So times 2 times 0 will give us 0. So you put that one here, right? Now, you are going to hold on to this part. So this will give us what? 1. We are holding on to the what? The integer part as 1. Then we'll take the fractional part again. So the fractional part will give us 0.25 multiplied by 2, right? This will give us 0. This will give us 0. You carry 1. That is 2 times 5 will give us 10. You put 0 and you carry 1. 2 times 2 will give us 4, plus that one, 5. 2 times 0 will give us 0. So this one, you hold this part, which is 0. 0. Then you take the fractional part again. So the fractional part is what? 0.500. Multiply by 2. So 2 times 2 will give us 0. 2 times 0 will give us 0. 2 times 0 will give us 0. 2 times 5 will give us 10. So you put the 0 and you carry 1. 2 times 0 is 0. Plus that one, that is 1. So this part, you take this integer part, which is 1. So counting again, 101. So the fractional part will now become 0.101. Add it to this one. That will give you 101.101. So this is what? Base 2. So that is how you convert this one to this in binary. I hope you are clear. I've actually done this conversion in the last class, but let me still do it in this class so that you will see it clearly. So how to return this one back to this is simple. So we are returning this base binary, which is base 2, back to decimal. So that will now be 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. So 1, 0, 1, 1, 0, 1, right? Okay. Now, because of this radix point, where are we going to put, where are we going to start our exponent 0? So 1, 0, 1, then the radix point. So this is 1. So radix point will, start, will keep the exponent 0 here. Then this is 1, and then this is 2. Now, to the right of the exponent 0, we are going to have minus 1, minus 2, and then minus 3, right? That's what we have. Now, this one will give us 2 raised power 2, that is 4 times 1. So that is 4, plus 2 raised power 1 is 2, times 0 will give us 0, plus 2 raised power 0, we told you anything raised power 0 is what? 1. That is the anchor point of any system. So without that, we couldn't have been able to build a system. So 2 raised power 0 is what? 1 times 1. That is 1. Plus, now this is the same thing as 1 over 2 raised power 1, which is what? 1 over 2. And this will give us 0 0.5. That is 2 going to 1. It cannot. That is 0. You add 0 to this. That is 10. 2 going to 10 will give you 5. Okay. Now, this one will be what? Plus 0 0.5. Plus, this is the same thing as 1 over 4, which will give us 0 0.25. So that will give us 0 0.25. So this one will give us 0 0.25, plus this is the same thing as 1 over 8, 2 raised power 3. That will give us what? 1 going to 1, 8 going to 1, that is 0. Going to 10 will give us 1. Going to 10 will give us 1. Remainder 2 going to 20 will give us 2. Remainder 4 going to 40 will give us 5. So 0 0.125. So plus 0 0.125, right? Now let's add everything. I told you the fact that you have this negative power doesn't mean that it is negative number. So the difference between power and number. Power will give you magnitude, number will give you direction. So on the number line, negative number will give you what? Direction. While negative power will give you what? Magnitude. So we are dealing with magnitude and direction. That is what we call vector in mathematics. We are still going to look at that. So what number system is showing you? It's showing you both magnitude and direction in number system. So let's add this up. So 4 plus 0 plus 1 is 5. So that will give you 5. That is 5 plus this position, this position. So you can see this is the first position, first position, first position. But in this one, when we did this place, yeah, this one is 2 raised power 1, that is 5. This one is 2 raised power 0 0.25 times 0, so this place is 0. So this is 0. So when we are adding it together, 5, 1, so this is this. So this will give you 0 0.516, then 25. 25. This is equals to 5.625. So that brings us back to our original number, right? So that is how you convert from binary, which is this, back to decimal. Hexadecimal is the same concept we are going to use. So if I want to deal with hexadecimal now, so that is for decimal. So converting hexadecimal to binary is very straightforward and simple. Why? Because when you have, so hexadecimal is what? Dealing with 4 bits. Hexadecimal is base 16, right? So base 16, that is what? Hexadecimal. So base 16, meaning we have 16 digits. So if you do 2 raised power 4, is equals to what? 16. So it means we are dealing with just 4 bits. And I told you it is very easy to convert binary to what? To hexadecimal and then to decimal. So engineers prefer using hexadecimal for memory. So if I'm to convert A3.F, this is base 16, to what? To binary. This is going to be very straightforward and easy. So what do I do? Now, I gave you the number system. So for binary, we are just dealing with 4 bits. So for hexadecimal is 0, 0, 0, 0, right? 0, 0, 0, 1. And just following the pattern. So this is 1. So it will be 0, 0, 0, 1, 0. That is 0, 1, 0, 1, like that. 0, 0, 1, 1. Just continue. 0, 0, 1, 1. Right? So this is what? This is 3. Now, when we get to A, and you know, hexadecimal is 0 to what? To 9. Then A to what? To F. A, B, C, D. A, B, C, D, E, F. That is what hexadecimal is. So when you get to 9, 10 is what? A, which is 1, 0, 1, 0. And then this F is what? 1, 1, 1, 1. And then 3 is what? 0, 0, 1, 1. So you slot this straight into this place. A is what? 1, 0, 1, 0. And then 3 is what? You space it 0, 0, 1, 1. And then you put this dot here. F is what? 1, 1, 1, 1. So join them together. That will give you 1, 0, 1, 0, 0, 0, 1, 1, dot 1, 1, 1, 1. So this is converting hexadecimal to binary. All you simply need to do is look at all the symbols, convert them to what? To their binary format, then join them together. So that is why it is very easy for engineers to prefer to convert binary to what? Hexadecimal, and then from hexadecimal to what? To decimal. So this is how you convert. Just convert each of the symbols to their binary format and then put them together, because it's very easy for you to obtain 16 from what? From binary, which is 2 raised power 4 equals to what? 16. So just convert it to what? 4 bits and then put them together. So that is how you do binary to hexadecimal to binary, and then you can convert it back by multiplying it by what? Base 16. So don't forget to give me a thumbs up, and don't forget to subscribe if you have not done so. So the next class we'll look at how this radix point moves, and that will give birth to another system called the floating point system. So till we see in the next class. Bye-bye.